Okay, so hi everyone. Today we're going to be working on a problem using Polya's four-stage model of problem solving. And the four stages of Polya's model are basically 1. Understand the problem, 2. Devise a plan to solve the problem, 3. Carry out the plan, and 4. Look back at your plan to examine your solution. Now the Australian curriculum states that problem solving is a necessary skill for 21st century citizens, and it's an integral part of the study of mathematics. For example, one of the Year 3 curriculum content descriptors for maths says that children should be able to represent and solve problems using efficient mental and written strategies. So, let's start with an explanation of the problem. On the coast, there are 3 lighthouses. The first light shines for 3 seconds, then is off for 3 seconds. The second light shines for 4 seconds, then is off for 4 seconds, and the third light shines for 5 seconds and then is off for 5 seconds. And all 3 lights have just come on together. So the first question is, when is the first time that all 3 lights will be off? And the second question is, when is the first time that all 3 lights will come on at the same moment? This is a great problem for Year 3 and 4 students to engage with, as some of the Australian curriculum content descriptors for this level emphasise exploring and describing number patterns and collecting, organising and interpreting data. So let's move on to stage 1, understand the problem. Polya's method emphasises careful consideration of the problem, because if you can't understand the problem well, you can't give a good solution. So this means understanding of the wording of the problem, and it also means understanding actually if there's enough information supplied to actually solve the problem. So there's a few things that come to mind when I think about this problem, and I've got a mind map here. So there's repeated addition, skip counting, multiplication, number patterns and number sequences. We need to organise the data, so we need a good method of data representation, and then we need to analyse the data. Okay, so we can see that we've been supplied enough information to solve the problem. Now we need to devise a plan for solving it. And Polya suggests several strategies for problem solving, from as simple as guess and then check if you're correct, to making a picture to represent the problem, to solving a simpler problem that's related, or to looking for a pattern. And I think that what we need for this problem is some form of data representation that will help us to get our heads around the job. So what I've chosen to do is to use 3 parallel number lines that will represent the 3 different lighthouses, and then we should be able to see when those lighthouses align at the right times of on and off. So if we come in here, I've organised it like this. It's on for 5 seconds, 1, 2, 3, 4, 5, and off for 5 seconds, 1, 2, 3, 4, 5. It's on for 4 seconds, the second lighthouse, 1, 2, 3, 4, and off for 4 seconds. And the same with the 3-second lighthouse. So by looking at our chart, we can see that at only the 6-second mark, the lights are off. So the first question is rather easy to solve. But now we'll move on to the second question. Okay. The second question is, when do all the lights come on at the same time? Now this is where Polya's first stage of understanding the problem is important, because the question isn't when will all the lights be on at the same time, but when will all 3 simultaneously go from a state of being off to being on. And actually, this took longer than I expected. Can you just pan around there? Just follow it around. The answer to this didn't come out until the 121st second mark. At 120 seconds we can see that all 3 lighthouses are off, and that at 121 seconds we can see that all 3 lighthouses have simultaneously come on. Get this coming out. Okay, so I would suggest that as teachers, when we get students to do something like this, it'd be good to do it as a collaborative activity. That way the students can assist one another to write things down correctly, to check one another for mistakes, and it'll also make the whole process happen a little bit faster. Okay, now we're going to move on to the 4th stage, review. And Polya predicted that in reviewing the method, This helps us to learn if we could have done it a better way and where this method might be useful in the future. So when reflecting on this method, we discover several things. First, we discover that the first answer happens very quickly at the 6-second mark, but the second question requires a lot more writing on the number line. So a number line might not be the best visual way to represent this problem. Perhaps we're better doing it in the form of a chart like this. And we can ask some questions about patterns too when we look at the chart. The first thing that becomes apparent is that all the 5-second lighthouse intervals are on the left-hand side. So they're from 1 to 5, from 11 to 15, from 21 to 25. So whatever the answer is, it must be 1 or 11 or 21 or 71 or 101. So what's needed then is for us to work out when the 4-second and the 3-second intervals will align with that. So this can be an interesting activity also that the children might be able to work on further or work out another way to do it. Also, if we wanted to ask a bigger question such as when will the lighthouses come on for the 7th time altogether, in understanding what the pattern is, it'll be much easier than writing a several hundred long number line. So this reflection stage is important. It helps students to develop more as problem solvers and to see what better methods they can use in the future. So, all right. Thank you very much.